Right. Good morning, everyone, and welcome to Monday. And what I thought is that we are quite a way through the lecture slides. So today, what I would like to do is to have two practice sessions rather than a lecture and a practice session. So what we're going to do is we're going to try. The most important thing now is to prepare the proteins, the receptors for docking, for molecular docking. That is the most important. And then maybe in the second session, maybe I can then just check with you if there are any problems that you've got, and we'll maybe try and troubleshoot what problems you have. Okay, so there are several receptors that we need to be worried about. And so what I'm going to do is I've got to rcsb.org. So I'm going to just search for those appropriate ones. Of course, don't feel limited by what I've given you, the receptors I've given you. There are many other receptors for the COVID-19 main protease. And if you search down, you can see on the main site, there's a lot of coronavirus resources on RCSB. So please, but of course, what I'm interested in now is I want just these ones for the task I've spoken. So I'll start with 5-RFC, and maybe you can start to see some of the issues you might run into. So I'm not going to download, even though it says download straight away, please don't do that. We can use Babel with whatever we download, that's fine, but I'd prefer to just go click actually on it and not be on the search place, because we then have a lot more options on download files. And so it's the PDB format that I really want here. And I'm going to save it. And I'm going to save it. I'm going to create a new folder. And these are my receptors. Okay, so 5-REC, I've found the PDB format. We've got 5-REY. Okay, and that I'm already in the right place, so I don't have to click on it on 5-REY. I can just save the PDB format. We have got some other ones, 5-RFE. Okay. Now I'm not in the place, so I need to go into it. So you see this download is not giving us options. So just go into 5-RFE. And now we have some options for PDB download. Okay, save. I just want to check that we've got the chat available. I can't see where the chat is on this. Chat. Okay, if you've got, please shout up if you've got a question. Okay. And I'm not seeing the search hand, so we've got 5-RFE. We've got to get 5-RFT is the next one. And I'm in the right place, so. Now, what I've given you is what I've asked you to look at is like a worst case scenario. These are receptors that have got multiple conformations in them. Not if you're looking at different receptors, you might not have multiple conformations. And so this is the last one. So you might not have to do all the steps that I have to do of copying to the cluster to extract just one conformation. But really, I want you to be able to work with the worst case receptor that gets thrown at you. Okay. And so now, I have all of the receptors. Okay. So I've downloaded all of the receptors onto this computer. Okay. So if you have got a Discovery Studio Visualizer, it's very nice to look at at them in Discovery Studio, because Discovery Studio gives you a lot of, it's very powerful in terms of looking at these structures. I also find Discovery Studio to be extremely reliable, and on most systems, it doesn't bomb out. So I use it quite a lot under Linux, but also under Windows as well. So here we go. Here's the 5REC structure. I didn't have to download it from RCSB. If you've got Discovery Studio, you can go File, Open URL, and I could have just typed in 5REC. So let me try 5REY, for instance, and see if that works. Okay, if you get a problem like that, then you can just, on the 5REY, just change that HTTPS at the top there. Just delete that S from the top, and then, yeah, and then that works no problem. So you can download it directly if you like. And so there are alternate ways if you've got Discovery Studio. But here I've got 5REC on my computer, and I've opened it directly from my computer. It's saved. And you can see, if you look very carefully, you can see the waters around. If you look closely, you can see the DMSO that we were going to delete. And if you also look, you can see there's a co-crystallized ligand, and I'm presuming that this is the binding site, and it would be nice to see if we can bind our own compounds or rebind this one using molecular docking to this protein. But of course, in Discovery Studio, the way to work with things is by looking at the hierarchy. And so you can go to View menu. On the View menu, you can go to Hierarchy, or notice there's a shortcut, Control-H. And that's really nice because you can select different parts. You can select the waters. And if you want to go and get rid of the waters and they're selected, all you have to do is press delete, and they are deleted. And of course, you can expand, there are two A groups, expand the second one, and you can see the dimethyl sulfoxide. You can select that one and press delete. You can select and press delete, and select and press delete, and so on. And then you've got a co-crystallized ligand here. What's nice with Discovery Studio is we want to know the rough XYZ coordinates of that active site. And so you can select an atom in the active site, and you just go to the attributes of that atom. And you can see straight away that atom I chose, you see it's yellow there, is roughly the middle of a ligand. And so the XYZ coordinates I get are 22.7, 15.4, and 4.5. That will be a really, really good center for our search area if we want to get another ligand and dock it to the active site of this. So the co-crystallized ligand has a lot of information. But what I'm going to do with the co-crystallized ligand, if I'm working with Discovery Studio, is I can select it, and I go and edit, cut, and let's go File, a new molecule, and I can then paste it there, and so I can separate it, and I can save it as my co-crystallized ligand. Okay. But this doesn't have, as far as I know, maybe you'll find for me, this still doesn't have a good way for getting rid of the conformations, the two different conformations of this protein. So if I just go to my display style and just have it as line, I'm not sure if we'll be able to see easily the different conformations that are causing problems in here. I can't see them readily. I may have to zoom in a little and look carefully, but what happens if you've got two conformations is you'll find that the side chains, there are two versions of a side chain of an amino acid, and they overlap each other. So I can't easily see here. There we go. I have found it. So have a look here. So let's zoom in on this. Can you see this over here? This here. And that is as 216. I'm going to make, I'm going to the hierarchy to look for 216. And I'm going to make the display style as a stick. So these are the problems with the two different conformations that we've got here. So you can see one conformation is in normal color. So I think this is aspartic acid. You can see the carboxylate is, there's a normal color and there's a blue. So those two conformations are in this one file. And so you can see that this file contains more than the number of atoms in this structure because it contains multiple conformations of that. So if you expand it, you'll see that there is a second conformation, a B conformation, and it's got different coordinates. It's got a separate set of coordinates, and those atoms there are duplicated. The N, the Ca, the CO, Cb, Cg, all of those elements are duplicated in that conformation. And so that is why, for this particular structure, we went onto the cluster and we separated into those different conformations. So that's exactly what I'm going to do now. I suppose in here, what I could actually do is I could select the atoms and I could, no, it won't let me do that. I think it deletes both. But there may be a way that you can in here remove an alternate conformation. But what I want to do, what I'm going to do is without saving anything, is I'm going to take these across the cluster using WinSCP. And I'm going to try and do the minimum work I can. And so let's go to carbon.ru.ac.za. I'm going to log in as me. Okay. And I'm going to copy my receptors across so that I can fix them on the cluster. And so it's on the desktop. So the receptors, I'll just drag it across, drag the receptors onto there. And that contains all my PDBs. I'll drag that folder onto the cluster. We're going to have a slight complication. Is that all of them are in a folder. So just to, okay, it's taking a bit of a moment. So just to prevent confusion, what I'm going to do is I'm going to quickly delete the 5REC that I have that's not in the folder. Okay, so there's 5REC all over the way to here that's not in the folder because what I want is the receptors that are in the receptor folder. So those three are in the receptor folder. If I go out of it, you can see they're not there. So that's going to cause some interesting issues when we log on to using PuTTY. So let's go on to carbon using PuTTY. And I'm going to open. Okay, so the problem is this. If I go ls, you can see that I can see my ligands, but I can't see my receptors. Oh, there's the folder. There's receptors, but I can't see, when I type the listing, I can't see anything in the receptor folder. Okay. So what we're going to have to do is we are going to have to move into that folder. And the way to do that is to type cd, to change directory into the receptor folder. and I can use the tab completion. Notice that there's only one thing that on this that starts with RE. So if I type RE and press tab, it knows that there's only one thing there. So tab completion speeds up things. And when I press enter, I'm now on your terminal. Your terminals are fixed. It'll tell you you're in the receptors folder. And when you type ls, you can see that you are definitely in that folder. You can't see what was in the root folder anymore. You can only see what's in the receptors folder. If you type pwd, it will tell you exactly the path where you're at. And I'm in the folder, in my home folder, in the Kevnell folder. I'm in the receptors folder. Okay. So the module we need to be able to work with is Autodoc Tools module. I just find it easier to work on the cluster than to set paths, etc. on the Windows machine. And we have it already available here. So I'm going to module add Autodoc MGL Tools. So if you select and you right click, it will paste if you're using PuTTY. And so I've got my MGL Tools. And so now what I want to do is to get the A confirmations for all of these. So let's go prepare PDB, and you do -R, and then it's 5rec dot PDB. So there's the first one. And then to speed things along, I'm going to press the up arrow. I'm going to use the arrow keys on my keyboard, and I'm going to move with the arrow keys. You can't use a mouse for this, but you can do that. And I just need to change that C to a Y to work with the next one, with the 5REY. I'm going to press up arrow, and I'm going to change it to RFE. So I'm splitting. That's interesting with RFE. There are 4 confirmations that we end up with. I'm just going to use the A1. Okay. And then we have RFT. If you don't press the up arrow, you're going to have to type all of this exactly as I've written it there. Okay. And then finally, I'm going to work with 6W. And there's only one thing in this directory with 6, so I'm going to press tab, and that will type it in for me. Okay. So now I've split the confirmations, and so now I need those A confirmations to come back. I'm going to try and see if I can work with the A confirmations. If Autodoc Tools gives issues, I might do the additional step that we had before, but let's see what happens. So I want to copy them. So let's open receptors on that side and receptors on this side, but I haven't refreshed on the cluster. Let's refresh. And you can see there's a whole lot of confirmations. And I'm just going to take the A1s, and I'm going to control click just to select. So if I click with control, it allows me to just select those A1s. Or you can copy them one by one. It's fine. You can drag A across, drag A across, drag. I'm just going to select them, and I'll drag all of those across. And let's see if we can work with Autodoc Tools. Okay. Now, the thing is with Autodoc Tools, Autodoc Tools is a really powerful program, and it's a free program, so I don't complain if there are any issues with it. But what I found is that if you restart it regularly, have a fresh workspace, then some of the issues go away, not all of them. So we just must be careful, and we must be patient using Autodoc Tools. Now, of course, for those who are happy with the terminal, with PuTTY, a lot of what we do with Autodoc Tools, we can do by simply typing into the terminal. And some of my notes show you what you can simply type in on the cluster to do some of the tasks that we're doing now. Okay, so I'm going to go to Autodoc Tools. Please, Autodoc Tools is not the same as Autodoc. Autodoc Tools is the graphic front end that allows you to connect with Autodoc and with Autodoc Vina or Vina. Okay, so please, there's a lot to be installed. So we need to install Autodoc Tools, and we need to install Autodoc, and we all need to install Vina as well. Okay, right, so here we go. the first thing I do when I open AutoDoc is I try to make sure that the settings are right. So I go to the preferences, and I set the preferences. Now I see the startup directory is not on my desktop. It's not in that receptors directory where I want it to be. So I just type some rubbish there and try and set the rubbish, and it complains, but then it allows me to get to the desktop. Okay, so on the desktop, there's a receptors folder, and that's where I want to be. So it's in the receptors folder where I copied everything, and that's fine, and I can set it. Okay, and I can close that. So when I open it, I'm straight in that folder, and we can see. So let's start with 5rec A. Okay, there it is. And you can see that the waters are there. And so I'm going to start by deleting the waters. And the waters are now deleted. So edit, delete waters. I'm going to then in A, I'm going to expand it, and I need to just remove these dimethyl sulfoxide. Okay, so there they are. So there's 1, 2, 3, 4. Not all of these molecules have dimethyl sulfoxide, and I'm going to edit and delete the selected atoms and continue. That's fine. Okay, so that's all taken away. Then we've got the T1J, our ligand. So I'm just going to highlight it just to show where it is. So that is the co-crystallized ligand. It would be nice to save it as a reference. So what you do is you select it and you go File, Save, and I'm going to write it as a PDB. And that there is 5rec A, and that is the co-crystallized. So I'm just going to, over here, change its name to being 5, and that's a co-crystallized ligand. Okay, so we save it, and then I'm going to edit and delete the selected atoms to delete the co-crystallized ligand, and continue, and now it's gone, and now we've got the apoprotein. So what I want to do straight away is I'm going to save as a PDB. We'll come back to it. I don't want to redo any of this work, so I'm going to just save it as apo.pdb. Okay, right. I'm going to try and not restart AutoDoc tools. Let's try another one, but let's delete the current molecule, and let's just open the next one. So 5REYA, not 5REY, that contains 2 conformations. The one conformation that I've got now back from the cluster. So conformation A. We can do the same thing again. First thing, delete waters. Okay. And second thing is I need to find those DMSOs, and we can delete those. Okay. I see there are 3 of them. There may be 4. Let's 3. Yes, just 3. So edit, delete selected atoms, continue. And here's our co-crystallized ligand. Here we go. I'm going to just maybe make it larger so we can see what it looks like. There it is. And so I'm going to File, Save, write PDB, and now it's 5REYA, and that is co-crystallized. Okay, and edit, delete selected atoms, continue, and File, Save, write PDB. So this is now the protein structure without any ligands inside. So this is, I'm going to call it APO. So it's the APO protein. Okay, right. I'm going to see if AutoDoc will, AutoDoc tools will carry on working if I delete the molecule. Let's open another one. So we've done 5REC, we've done 5REY. I'm going to try and do 5RFE. Okay. Same thing again, edit, delete water, expand the hierarchy, Okay, again, the 3 DMSOs to delete, edit, delete selected atoms. Okay, and then here is our co-crystallized ligand. Here we go. There's a co-crystallized ligand, and what I'm going to do, it's selected, it's yellow, so I'm going to save it as PDB. And so just as a reference, so that when we come back, we can, if we do molecular docking and we redock it, we need to get back to this conformation. Okay. And then I can go edit, delete selected atoms, continue. Okay. And file, save, and I'm going to write a PDB here, and now it's the APO. And of course, I can do it with the other two as well, and maybe I will in the time before. Okay, but what I'm trying to do is I'm trying to build up a list. I'm going to close AutoDoc Tools so we can come back to it. So what I've got in my, there we go, there's my receptor, is that I've got a whole lot of PDB files. Here's the co-crystallized ligand, it's a very small file. Here's the other co-crystallized ligand, it's very small. Here's the other co-crystallized. I still haven't done my work on 5-RFT and 6-WNP. I haven't done those. But of course, now we've got the apoprotein. Those 3 apoproteins are now good to go. But the problem is that they're in PDB format, and we're going to need to get them into PDB-QT format. Okay, so I'm just going to start with a fresh instance of AutoDoc Tools. And let's see if we can treat the proteins and get them ready for work. And let's see if we can do all the work here, or if we're going to need to go to the cluster. Okay, so first thing is I want to just set my preferences and just, okay, our meeting's got 10 minutes, so I'll be 5 minutes. So let's just set our folder to be correct. Desktop receptors is where everything is. And then we can close that. Let's see if we can get a PDB-QT or whether we have to use a cluster. Okay, so here's 5-Rec-A APO. I'm going to open that. And there we have the APO protein. And I've got a fresh workspace with it. And so what I'm going to do is edit. And with hydrogens, notice there are no hydrogens here. So when I add, rather than adding all hydrogens and then removing the non-polar ones, which what we need to do, is I'm just going to add polar hydrogens only. Okay, so last time I intentionally added all hydrogens to show you what it looked like with all hydrogens on the receptor. But this time, what I'm going to do is just add the polar only. Okay, so you can see only where hydrogen bonding is going to occur are you seeing hydrogens being added. Now, there are another 2 things we need to do. We need to make sure the charges are set for the electrostatic term. So I'm going to compute gas-to-get charges, and it's added a total of charge of -3 to the system, but all of those atoms have partial charges. Okay, and then finally, we need on the atoms to set the AutoDoc 4 type to all of those atoms. And now what I can do is file, I can save, and I can write a PDB-QT. And let's see if this will occur without error. I don't need to change the name because it'll also automatically update the extension to PDB-QT. And so this system is now saved as PDB-QT. So the only thing I needed to do on the cluster was to split the conformations. Okay. So let's just now, let's try and delete. And let's open the next one. So you can see we've got the PDB-QT. So let's open the next APO one, 5-REY. Same thing again. Edit, hydrogens, add, and I'm only going to add the polar hydrogens. Okay. Edit, charges, compute gas-to-go. Okay. Edit, atoms, assign AutoDoc 4 type, and file, save, write PBQT. Okay, right. So that's all set, and I'm going to then delete this molecule. And I right-click to select and delete it. That worked fine. So let's open here. And we've got the other APO to work with. Here we go. Edit, hydrogens, add, and I'm just doing polar only. Please be careful. If you've got a protein that has hydrogens all over it to start off with, then you need to make sure that you merge the non-polar. So you make sure that you remove some of the hydrogens before you proceed. Okay, then edit charges, compute gas figure. That's fine. And edit atoms, assign order.forward type, and then file, save, write PBQT. Okay, so what I've got now is I've got 3 receptors. Okay, and so this is fantastic. We don't have to do that with any of those receptors again. Those receptors can be used in any situation for any docking that you want. So if I just close this, okay, so that apo.pdqt, that apo.pdqt, those 3 receptors can be used now for molecular docking. Of course, what we need to know for molecular docking is where is the actual position of the active site. And we'll try and work that in the next session. Are there any questions before I shut down for 10 minutes?
Prof.
Yes?
The question is not about today's stuff, it's about last week's stuff.
Okay. Yes. Perfect. Yeah.
Some of the molecules, when we're opening in Avogadro, only show the orbitals and do not show the vibrations tab.
Okay, so what I'd like to do is troubleshoot that. So in our next session, the first thing I'm going to do is I want you to tell me the names of one system that's giving problems. And I will copy it from your data set and I will open an Avogadro on mine. We'll try and figure out what's wrong. Okay.
Okay.
Okay, perfect. Okay.
Yeah.
Okay. So please, can we meet at, can we make it 15 minutes? No, make it 10 minutes. So at 9:45. Can we meet at 9:45? Okay.